Hello, my name is Krista Beranger, and this is my presentation on taking up problems in early engineering courses. When I started studying engineering, there were a lot of students that would talk about the weed out courses. They were basically saying that early engineering courses were so hard that all the students that aren't meant to be engineers will fail them. But what students fail to realize is that these weed out courses typically don't even assign problems that real engineers would solve. The courses follow the textbook very closely, and the questions only have one right answer. While textbook problems are important for practicing using equations, they really don't offer the chance to practice real-world problems that professional engineers will face. Here are two examples of problems from a statics textbook and a dynamics textbook. Both of these problems have all the information that is needed in the problem and a single numerical solution in the back of the textbook. These problems are okay, and the classes are fine. They're not meant to weed out engineers. They just might be limited in what they're teaching. The research in this presentation is part of a larger project that looks at students' engineering judgment. I'm an undergraduate researcher, and this research project is led by Dr. Jessica Swenson. This project is based on the concept of engineering judgment, as written by Julie Gainsbourg. Engineering judgment is defined as 8 different decisions she observed structural engineers use to solve problems at work. Previous research on the project has led to the development of open-ended modeling problems. Professors would assign these new design problems in their class in place of homeworks or projects. The goal of these problems is to allow students to practice solving ill-defined realistic problems that have no right answers. The image on the right shows the eye walk, which is a crush that was analyzed in some of these classes. For this project, the first thing we did was ask 2 research questions that we hoped to answer after going through the data. They were, firstly, how do students take up open-ended modeling problems? And secondly, what indicators do we have as to why students take up problems in that way? After posing these questions, we went through and highlighted quotes from student interviews to get data. These interviews were conducted after they completed an OEMP as part of their classwork. We looked for quotes where we could interpret how they took up the problem and also the reasoning they might have expressed. Through looking at the interviews, we found that there were mainly 2 ways that students took up a problem. They would either take it up as they would a traditional textbook homework, or they took it up as a real engineering task. Students that thought they were doing a homework usually are concerned with the expectations of the teacher or the grader. These students indicated that their assignments were good enough or complete enough for getting a grade that they were okay with. Sometimes they even mentioned doing the assignment just for the extra credit. Students that fell into this category also sometimes thought that the assignment had only one correct answer. On the other hand, students who felt they were doing real engineering did extra research or noted that they felt like they were thinking in a way a real engineer would when designing. These students also mentioned optimization programs they made that would repetitively solve the problem to get the most ideal answer. After reading many interviews, we found 3 main rationales for why students took up the problem in a certain way. As seen in this quote, many students commented on time-related issues that caused them to put in less work to the problem. In this quote, the student is saying they could have gotten a better answer, but they didn't want to put in extra time to do it. Another rationale we saw in the interviews was that students were doing the best that they could given the knowledge they had. They knew their answer was not the best, but they said it was good enough for the class. Another trend in the data was that students took up the problem as real engineering because they saw the task as something they would do after graduation. They thought there was a big connect between the work they were doing in school and what they would do in a job. In this quote, the student is saying that they felt good because they felt like they were actually doing something that they would be assigned to in their job. These quotes can give us insight as to where students need improvement, such as giving them more time or knowledge, and also how we can design problems that are more engaging for students. If we assign tasks that are more interesting to students, they might feel more engaged because they see the connect between what they will do after graduation and what they're doing right now in school. This will improve their understanding of the content and maybe even make them better engineers. That concludes my presentation. I'm Krista Beranger, and thank you for watching.